Hello, everyone, and welcome to today's session on Google Cloud Platform data and AI products. Thank you for taking time out and being here today, and that too on a Saturday. Today, I have with me Hasan Rafiq, who is cloud and ML architect with the top technology and consulting firm. He has multiple badges to his name, but when it comes to GCP, he's a Google Cloud certified data engineer as well as Google Cloud certified ML engineer. Welcome, Hasan, to the show. Rather, I would say welcome back, Hasan. Hasan has already been in this show where he covered end-to-end TensorFlow pipeline. You must check it out. And if you want to know how to use TensorFlow in real-world pipeline, that is a very good webinar that Hasan did. You can go and check it out in my channel, or I will also post that link in this particular video description after this particular streaming is done. Hasan, welcome back to the show.
Okay. Thanks, Shri, and thanks for bringing me back on the channel. It feels great to be a part of this community, and I guess we have a lot of interesting topics to cover today.
Right.
So let's start then. Let's not waste. Thanks a
Sure.
lot.
Sure. So let's get started. The way we are going to talk about today is basically we are going to understand the Google Cloud data and AI ecosystem. It is pretty key. If you're getting started in Google Cloud, at least you need to know what are the data products available and what are the AI products and services available. Right, that is one part of it. Second is we will understand more about professional ML engineer certification coverage. This is one of the certificate that was recently launched, maybe hardly a couple of months, and Hasan has been one of the early takers of the certificate, and he has cleared it as well. That is a big achievement because knowing Google Cloud certificates that I have taken in the past, it is relatively tougher when it comes to the data and AI side. We will also talk about how to prepare for the certification. If you want to add it to your profile, the cloud certifications are very relevant today, be it AWS or Azure or GCP. And we'll see how you can prepare for the GCP certification, what are the resources. And we'll also go into detail. While this particular webinar is going to touch the data and AI ecosystem on a higher level, but we will go into the details of the resources that you need to use to learn more about Google Cloud AI products. So let me get started. A typical data lifecycle looks this way, right? You have four key components to a data lifecycle. Now, this data lifecycle is common wherever you build your products. It can be on-premise, it can be AWS, it can be Azure, or it can be GCP. You can basically, the only thing that changes is the components that you want to fit into each of these phases. While you can use the same component across all the environment, but when you're in cloud, you typically want to go cloud native, right? And we will talk about the products that GCP has in each of the stages. But to understand a data lifecycle, basically you typically have your ingest, store, process, analyze, and explore and visualize, right? When you talk about ingest, typically an enterprise data comes from multiple ecosystems. It can be your legacy mainframe system, it can be IoT sensors, it can be your relational databases, it can be your data warehouse, it can be flat files. There are a lot of places where your data comes in an enterprise, right? And the very first step you do is you collect the data from these various sources and ingest it, and you ingest it into an storage area. Now this storage again depends on the consumption application. Sometimes you want the storage to be analytics oriented, so basically you want to run heavy analytical job like AI ML or other batch processes. Sometimes you want it for your dashboard and visualization, where you want more like low latency querying, right? And sometimes you want to just ingest tons and tons of real-time data, and that's where you need something like a NoSQL database. So the storage varies based on your consumption pattern, how you want to consume from your downstream application. It can be a web application, it can be your basically, just give me a minute. Yeah, it can be your web application, it can be, yeah. Yeah. So, and it can be any application. And once you have the data stored, basically what you do is you process and analyze your data. Now, if you see the process and analyze, they are in two places. Now you have the process and analyze on the top as well as here, and that's where the type of application determines it. Sometimes you want your data to be completely analyze to completely analyze after the fact has happened. So that's what we call like basically batch ecosystem, right? You take your data, you store it either in a data warehouse or data lake, and you do your analysis. And typically your AI/ML model, when you build your model, you typically store and analyze or store and process, right? Now there are other applications where you need data to be actioned on as and when the event happens. Let's take a typical example of cybersecurity. So somebody comes into your network. Now you want to know that somebody has come into your network immediately, not after the fact. And that's where the real-time system comes into play. So if you see this particular ingest and process analyst of your system, where you take the data, you process and analyze, and then you store it, that is where your real-time systems, like you can be a credit card fraud detection system, it can be a cyber security system, or it can be any real-time oriented system where you want to action on the data as and when your event happens. That is one part. And then you store it. You store both the raw information as well as processed information. The second category is you want to do it after the fact, and that's where this part of process and analyze comes into play. So this process and analyze can be anything. It can be your data engineering jobs, it can be your AI/ML jobs, or it can be your batch and a batch oriented workload. It can be anything. And once you have processed and analyzed the data, you basically action on it. And how do you action on it? If you have an AI/ML model, you try to deploy it in your application, and then you basically try to infer on real time the instances that are coming in, or you build dashboards, you build like the reporting systems to basically communicate your results to the end users, right? This is a typical data life cycle. Now if you see Google Cloud, there are separate products for each of these components. So we will look at that quickly. There are a lot of products, in fact. And here it is, right? You can use even non GCP product on GCP. If you want to run just like Apache Spark, you can use it. But at that time, what you are doing is you are taking care of all the infrastructure headache, you are taking care of the all the management side of it. There are too much complexities involved. The purpose of any application is basically you are solving a business problem, and you don't want to get into all the administration and everything. Even though in some cases you want to get into it, sometimes you want more like a managed service, and that's where your GCP specific service comes into play. So now mapping to the four phases that we spoke about, GCP on the ingest side as a set of products. I'm going to more focus on store, process, and analyze, because that's where typically a data and AI person comes into play, or even the explore and visualize, where we typically communicate our results, right? Now, when you talk about ingest, as I said, your data can be federated across multiple systems. It can be a mainframe system, it can be sensors, IoTs that are coming in, and you will have your application running that is catering to your end customers. This where like you may have your application, it can be Java Spring application, it can be and any other like application that is written in .NET, or even a Python application. You may deploy it in multiple services that Google have. It can be like a app engine or compute engine or Google Kubernetes engine. So you're just having an application running which is collecting data and which is trying to get the data from different sources and send it to your storage layer. You can also, when you are migrating to cloud, basically you are on premise and you want to move on cloud, you have a lot of data in enterprise that you want to move on cloud. And for that, Google specifically has some service called transfer appliances. So say if you have terabytes of data that is sitting on premise and you want to move it to cloud, you can basically take that transfer appliance. So transfer appliance is something you go and lease the appliance from Google, you get it to your on-premise, you load the data in the transfer appliance and ship it to Google, and Google will load the data for you in their storage environment, right? So from the ingest side, there are a lot of components that are available. You can also run your custom component that is in the compute engine. So compute engine is nothing but a Unix environment that you get. You can deploy your own application, but only thing is you manage it, right? You manage the environment, you administer the environment, you take care of everything. If you want to go more kind of managed services, you can deploy the same application in App Engine or Kubernetes Engine or Cloud Run or anything, right? We will talk about it, like what are the resources to learn all this, because when you're deploying a model, typically you may use any of this environment. We will talk about this towards the end of the session. Now, once you have collected the data from different sources, you want to store the data. And for storing, GCP has multiple storage formats. You have cloud storage, which is nothing but an object storage environment. So if you have files, if you have images, if you have structured and unstructured data, you typically want to take it and dump it somewhere. And that's where cloud storage comes into play. On Google Cloud, cloud storage can also act as your data lake. So if you are building a data lake environment, cloud storage is a pretty good layer where you can store your raw information. Now, sometimes you may want transactions. When I say transactions, you want like ACID compliance property, you want like two-phase commit, or you need other things, and that's where Cloud SQL or Cloud Spanner comes into play. Cloud Spanner is in the bottom, and Cloud SQL is in the top of this particular image. So Cloud SQL are nothing but your relational databases. So if you are running PostgreSQL, if you are running MySQL, if you are running like SQL Server, Google Cloud supports them as a managed service in Cloud SQL. Now, typically, when you know about your relational database, it has limitation. It is good for data with few terabytes. But when you want to scale into petabyte or something like that, your SQL-oriented database might not be ideal, or even on a higher terabyte, it may not be ideal. So that's where Cloud Spanner comes into play. Now, Cloud Spanner is again like an ACID complaint database that Google Cloud provides, which you can use for scaling your SQL-based application. Now, Cloud SQL is kind of an vertical scaling system, right? When I say vertical scaling system, you want more compute, you go and add compute, you scale within the same box. But Cloud Spanner is a horizontal scalable system. So what you do is you add more nodes to it. Now, Cloud SQL can also horizontally scale, but then you kind of end up in the backend configuration of scaling it, and it becomes complex. Cloud Spanner does it for you in a managed service way. Now, the next step, you may have some document style systems, right? Like MongoDB, if you know, you want to just store and dump JSON records into the file. That's where data store comes into play. Cloud data store is again. I'm going to show a representation which you can easily understand. Big SQL is a NoSQL database. It supports basically white table. If you have IoT data that is coming continuously every millisecond from thousands of devices, you need high throughput data writes. Or if you have time series data that is coming continuously, like weather data per zip code, that's where Cloud Big Table comes into play. Now you have your data lake, but you want to build reports on top of it. Basically, data lake is not like an interactive querying environment. It does not support SQL in this case, like cloud storage, right? Now you want to provide it to your BI reports, or you want to provide it into any kind of data analyst or business analyst who want to query the data interactively. That's where Cloud BigQuery comes into play. Now, BigQuery is nothing but a data warehouse-like system. It can scale into petabytes, and it can provide you interactive querying. So these are the different storage components that are available in Google Cloud Platform. Now, from storage, we move into process and analyze. Now, in process and analyze, we have a set of platform. I'll cover each of it as we go into the details of it. Now, this is where your data processing system, data engineering system, or even the AI services comes into play. That is process and analyze. And then finally, we have explore and visualize, where we have kind of a reporting tool, or we can have like Excel kind of utility. So connected sheets is a product from Google, which is similar to Excel. You just load the data in Excel, and then you don't have a limitation of data. You can scale into higher terabytes of data in cloud connected sheets. It has same Excel like interface that your business is comfortable with, right? And then you have different BI tools. Your Looker you can use. You have Data Studio you can use. You can use Trifacta for data wrangling, as well as some amount of data visualization. So we will talk about it as we go into the details of it. Now, coming back to the storage layer, right? I said there are three layers which we will focus on: storage layer, and process and analyze layer, and explore and visualize is nothing but your reporting layer. Now, coming to storage layer, how will you choose your storage environment? There are multiple storage options that are available, right? This is a nice flowchart that is available on Google Cloud document, which you can use it. So when your data is completely structured, right? So what you do is you need to see whether your data needs transactional properties. When I say transactional properties, that is, does it need ACID compliance? Does it need two-phase commit? Or you want more like a SQL, like interactive querying? If that is the case, then you can use Cloud SQL or Cloud Spanner. So basically, if you have been using PostgreSQL, or if you have been using MySQL, and you're migrating into the cloud, that's where you more tend to go with Cloud SQL. But if your data has outgrown some 10 terabyte or 20 terabyte or 30 terabyte, Cloud SQL will become very slow for your purpose. Then you go to Cloud Spanner. So if you need transactional support and your data is structured, then you typically use these two. Your data is more analytical. You are building a data warehouse, right? Now that's where like your a BigQuery comes into play. Okay, now you are running reporting on top of it. You can even learn machine learning on top of BigQuery. BigQuery ML is basically a SQL based interface where you can develop your logistic regression model or time series arima model or any linear regression model using SQL syntaxes. So BigQuery supports both interactive SQL querying workload as well as machine learning workload. Then once you move from structured data to semi-structured data, right, that's where you need basically these NoSQL platforms. Cloud Data Store, when your data is completely a JSON file and you want to query on any attribute of the data file, right? You want to query with any JSON tag you want. You go with like fully indexed systems like Cloud Data Store. It is pretty similar to your MongoDB if you're aware of MongoDB. And again, coming back to what I said earlier, you can still use MongoDB, you can still use Cassandra, you can use everything on the cloud. There are providers who manage it for you. But if you want, I'm going to focus more on Google Cloud native services, because when you talk about professional exam, a lot of these questions will come from Google native services, while you will have question from others as well, right? The second part is key value based. Now, if you take a time series data, right, you on every day you are collecting thousands of data points. It can be per zip code or it can be per any other like dimensions. So that's where your cloud big table comes into play, where you can store data in a key value. But the difference is, in this case, it is fully indexed. In this case, you look up the data by the key. If you can still look up by the value as well, then your performance will not be as good as looking by the key, because your data in this case is distributed by the key. So your key in this case can be say like Google uses Bigtable for your storing your browsing history, right? So they will have like a unique cookie ID for you, and they will have all the things you have done on the web. That's how they know everything about you. So that's a good use case for key value pair. So you have your key as cookie ID, you have or something, it can be some unique identifier that they have created for you, and your values can be, okay, you browsed cnn.com, you browsed economictimes.com, you have done these links you have browsed. They know everything about you so that they can serve the right ad for you, and it can scale to petabytes. And that's why the cloud big table comes into play. Cloud big table can also do analytical querying for you. Okay. And finally, you have unstructured or even structured data. You just want to build a data lake. You don't want to define a schema. That's why the cloud storage comes into play. You can load, even though it says only unstructured, it can load both unstructured and structured data. But why do they say unstructured even for structured data? Because you are not defining a schema. You are dumping a CSV file, but you don't know what is there in the CSV file. So there are two mechanisms when you talk about data lake. There's a schema on read, there's a schema on write. So typically your BigQuery is schema on basically schema on write, right? You define a schema, you write it, and you can query to exactly know what are the column names. But when you talk about data lake, it is schema on read. You load the data first, and then you define your schema according to your need. And that's where cloud storage comes into play. Now let's go into the second option of it. Now we have our data, we have ingested our data, we have stored our data. How can we process, analyze, and query the data? Right? There are multiple services that are available. Cloud Data Proc is a managed Apache, Hadoop, and Spark environment. So if you have on-premise data which is running on Cloudera or any other clusters, Mapr cluster, and you're migrating to the cloud, you can still go with Cloudera. But if you want to go with more like cloud native services, that's where Cloud Data Proc comes into play. You can build your data engineering jobs. Spark also supports Spark ML. Cloud Data Proc also supports Dask for distribution. You can use your machine learning workload also on Cloud Data Proc. You can build like Spark ML jobs which are highly scalable, right? At one stage, your scikit-learn and Python and everything is good. It's good for your data when it fits in the memory. But when your data outgrows your individual memory requirement, you want to basically scale out it, right? You want to basically distribute your machine learning workload and run it. And that's where Apache Spark comes into play. And Spark is similar to your Pandas data frame. There is some learning, but it's not exactly similar, but the concept is pretty similar to it. The next comes is data flow. Now, data flow is Google Cloud's managed data processing engine. And now Dataproc, if you see, when you are dealing with streaming data, we saw in the earlier slide that we have streaming data, we have batch data. When you're dealing with streaming data, you can use Spark. But when you're dealing with when you are dealing with batch data, you can use typical Spark data frame. But when you are dealing with streaming data, you will use Spark Streaming. Now, Cloud Data Flow tries to integrate your streaming and batch pipeline into one, right? And it is based on Apache Beam. So Apache Beam is one other framework that Google has open sourced some time back. It is similar to Spark, but it does not have the community or the scale or the support like Spark, right? But here they are provided a managed environment for Apache Beam. Apache Beam can also run other frameworks like Flink or Spark and everything, but typically Apache Beam can run by itself as well. Okay, so like that's where the cloud data flow comes into play. I've been getting question on slides. Yes, the slides will be shared. I will share everything. I'm sorry if it's not clear. You can expand this particular like PPT or the video that you're seeing and see it. I'll share the slides and all the slides will be available for this. And you can in the initial page I have given link. This is the link to where I have picked it from. You can see like cloud.google.com solutions data lifecycle cloud platform. You can go and pick it from there as well. Okay. Then comes cloud data prep. Now, cloud data prep is nothing but there's a tool called Trifactor. Now, if you want to do a UI-driven data preparation, that's where cloud data prep comes into play. So you can just use UI to define your pipelines, define your processing and everything. That's where cloud data prep. And BigQuery, as I said, is nothing but an SQL complaint managed engine. It's not used for the process side. Typically, you can still use it, but it incurs a lot of cost. You don't want to pay huge amount of money for your engineering jobs. I will say cloud data proc and cloud data flow is the best for that. You can keep your cost under control. You can build you can build like more kind of clusters that you can spin up, use for your data engineering job. You can shut down and move out, right? But BigQuery, you can use it for more kind of creating your warehouse that you can use it for end user consumption. That's where BigQuery comes into play. Now, this is how it is when you are building a data warehouse in GCP, you use BigQuery. When you are using like Hadoop and Spark migration, you basically use Dataproc. And then when you are doing a real-time streaming analytics, basically these are different components. One component I did not cover is PubSub, right? Now, PubSub, if you see, is nothing but like a Kafka. Like if you know about Kafka, you want to stream events in real time, then PubSub is a nice managed service that Google Cloud provides. You can also use your Confluent environment on Google Cloud, or you can use a typical Kafka instance, but PubSub is a managed service. So when you are doing a real-time streaming application, you can use PubSub, Dataflow, or BigQuery. Okay. Now, next is like the machine learning on Google Cloud, right? Now, when we have moved from data, we have ingested the data, we have stored the data, and then finally what we are doing is we are kind of now going to analyze, process we have also covered the processing of the data, but there's one more thing, right? Now, typically your data engineering pipelines are where you are building your data warehouses, or you are building your aggregated views of the data. There may be cases where you want to run a machine learning model. Now, this is where it gets interesting. Right now, Google has multiple services for machine learning. You can even use your typical scikit-learn pipeline. You can use your XGBoost. You can use your PyTorch. Everything you can use it. But there are multiple layers which you should know when you're taking the professional exam. Like some are pretty much for data scientists and ML engineer. Some are for application developers. So let's start from the top of the pyramid. Now, there are a lot of pre-trained APIs that you can use. So take a speech to text, right? Speech to text is a very complex problem. Typically, an enterprise does not have tons of data to run speech to text, to train speech to text models. Or it can be even like you want to detect an object from an image. You want to detect what is there in the image. You don't want to really train. These are all common things that are available. So you can use the ML pre-trained APIs that is available as REST service. You can just go and send your audio file. You will get the text data back. You can send an image. You will get what is there in the image. Now, that is a problem with what you will get, because you have some custom data in the image. it will not be able to retrieve that image part. And that's where what happens, you move out of ML API to auto ML. Now auto ML is basically you can customize. You have some custom image that you have some custom videos that you have some custom objects that you want to detect. You go into more like auto ML, where you can yeah, it's like a transfer learning process. You need some labeled images, you take that, you customize it, and then you can build your own model and you can deploy it and use it, right? Then you want to see, now at this stage you're still a citizen data scientist, right? You don't have to have a lot of knowledge. To use a ML API, it's very simple. It's UI driven some cases, or it is just a bunch of Python program that you need to call. Yeah, anyone can do it. Now auto ML, you just have to label some data. You need to use the interface or run some Python program and run a pre-trained model, right? You use BigQuery ML. If you're good in SQL, if you're good in SQL basically, or if you're good with data warehouse concept, if you're good with data engineering concept, you can use BigQuery ML to build your model. And finally, you have AI platform training, and that's where the data scientist work comes into play. You can train custom models. You can use scikit-learn, you can use XGBoost, you can use TensorFlow, PyTorch, you can build your own model, you can deploy it. And that's where like the AI platform comes into play. So as you come down the pyramid, the complexity increases, and you cannot use your auto ML for everything. In some cases, you have very custom data that you want to train. You have a lot of label data. You can use like AI platform training to build custom models. And you have Kubeflow, which is more like a Mlops environment, which can spin up infrastructure, which can set up your training pipeline, train and finally deploy it. You have Kubeflow, where your typical data scientist comes into play. If you don't want to use any of the Google services, fine, you can use the deep learning VM images. It comes with pre-installed frameworks like PyTorch, TensorFlow, or you can custom install it. And you can also use all the ML framework that are available. So this is how the ML on Google Cloud comes into play. Right now, this is basically the different cloud AI services. If you see on the top, you have your cloud vision. In the vision is basically anything to do with computer vision. So if you have images, if you have videos and everything, you can use cloud video intelligence service to detect objects from the videos or process video. You can use cloud vision to get details from images. You can use cloud auto ML vision to custom train your models and then use it. So yeah, if you want to detect like a semiconductor in your image, right, or semiconductor in a video, like you want to check whether that's a resistor or a transistor, maybe the default models are not trained. You want to customize it. That's where you can go and custom train it. Google also provides you a labeling service. So what you can do is, if you have a lot of data to label and you don't have people to label, you can just upload and provide them information and they will label it for you. So that is also possible. Now your vision, your language, which is more for text data. Similar to vision, you are like natural language processing, your translation systems, Google Cloud Translate, right? If you know like Translate, it's the translation runs on basically cloud translation service. It's very similar to that. You can convert from one language to another or whatever it is. You also have auto ML services where you can customize it. You have conversations, which are speech to text, chatbot, Dialogflow is the chatbot system, or if you want to do text to speech. These are all more kind of auto ML and AI services. If you come to bottom, these are all where you can build your own ML services, right? You can use their AI platform. Earlier it was Cloud ML Engine. This image is not completely updated. You can use Dataflow to also build your custom pipelines. You can use Dataproc, which is Spark ML. You can use BigQuery ML. You have a lot of options that are available over here. And you have accelerators. You can use GPUs or TPUs on Google Cloud. And you can use any ML libraries. If the ML libraries are not provided in the VM, don't worry. You can just do a pip install. And I have separate video for a lot of this. In case I will show you in the end, where you can go and learn practically all of this information. How can you spin up a VM instance, how you can install, and all this stuff. Now, when we talk about process and analyze, every data science process has a different life cycle to it. Now, when you're talking about reporting, KPI, dashboard, maybe there what you're doing is you're aggregating your data, you're keeping it for your dashboard to come into play. When you talk about machine learning, there is an entire process to it. Your ingest and prepare will be same, but then you basically have a lot of things where you want to use labeling services, you want to train it, you want to test and analyze it, you want to basically deploy it. And that this basically to show you what are the different services that are available in each of this. When you're ingesting data, I kind of already told you, you can use cloud storage to keep all your data, and you can use transfer appliances to move your data from your on-premise to cloud, or even move bulk data to your cloud. It need not be in on-premise. It can be actually in other cloud as well. So you can use all these things. You can use your cloud data prep and data proc and BigQuery for preparing the data. For pre-processing also, you can use data proc and data flow and BigQuery. AI Hub is kind of a centralized repository which you can use within your enterprise to share models. And to develop, you can use AI platform or notebooks, or you can use a custom VM image if you don't want to go with any Google Cloud services. And you can also use the labeling service to label the data. For training, you have platform training and Qflow. This Qflow is available also in the cloud. It is a little slightly older image which says on-premise, but Qflow is, you can use it in on-premise, you can move to cloud. So if you have a hybrid cloud infrastructure, you can use Qflow, where you can develop on-premise and move it to cloud and scale it. TFX tools are more kind of your Mlops pipeline, where you can monitor the model, you can evaluate the model, you can check different data within it. There are a lot of things that you can do in TFX. And finally, you can deploy the model using platform prediction, or you can also deploy the model using Kubernetes engine or app engine or like cloud engine or anything that you use on Google Cloud. So this is just to give an eye level view of all the stuff, things, right? The idea over here is we wanted to introduce you to different Google Cloud products, because when you are going into the certification, be it data engineering certification or ML engineer certification, this topic is more on ML engineer. You are, a lot of these questions will be very focused on Google Cloud products, while you will have generic concepts as well. Right now, with at this time, like I want to maybe hand it over to Hasan, who is going to more talk about the GCP Professional ML Engineer exam, and we are going to have some Q&A, and we will also like, if you have any specific questions, post it. If you are preparing for the exam, this is a very nice exam to add in your resume. The certification, this in SA, it can be any cloud, but today we are going to talk about Google Cloud Platform. Hasan, over to you.
Oh, thanks, Shri. Shri, do you want me to present? I have some
Yeah, go ahead.
changes.
Yeah, go ahead
Sure.
and present it.
All right. All right. I'm presenting my screen. Let me know if you can see it. Okay. All right. All right. I guess everyone was eagerly waiting for talking about talking about the main topic that we have today around certification for professional machine learning engineer. And thanks a lot, Shri. Before we start on that, the information that you shared was really great, and I think it would come handy to a lot of people who are there, who are viewing this for the first time, or even experienced people like me who are seeing things again and again, and there are a lot of things which I still miss out. Before I start, I just want to set up a context that all these views that I share are on my own personal. I do not represent my company or the developer community that I come from. So this is all as per my all experience. Now let's quickly dive through what the professional machine learning engineer examination is. If you go through the documentation provided by Google Cloud, you would actually see these two contexts over there. Um, on the left hand side, you can clearly see that the what is the job description of a professional machine learning engineer as per Google, and on the right hand side, what are the major six topics that they cover. So quickly walking through, and I won't be reading it because we want to open the session for Q&A. On the left hand side, a professional machine learning engineer is a person who basically builds models. He understands the business processes, creates KPIs for your business processes that you want to automate or optimize, and in the end, trains or productionizes model. And not only building model is the end of it, it's also the machine learning operationalization that starts from there. One of the core areas which a professional machine learning engineer has to focus even beyond ML model training is the ML ops, and that is primarily almost 40% focus in this examination. So if you see in the right hand side, it starts from ML problem framing, which is like how do you frame a problem from a business use case or a business fit or a gap that we call usually in the business terminology. How do you design an ML solution basically, and then how do you prepare data and process it? So this one is actually very important, which brings in information from the data engineering aspect of Google Cloud Platform. So if you would have attended the GCP data engineering examination, there is a lot of overmerge or overlap on this section and the professional ML engineer exam. Plus, next things which are coherent and specific to this examination is section 4, 5, and 6. Let me move forward. So, those were something which which you have in the documentation, but this is something which I prepared as per my own preparation. And while I was preparing for this examination, you should be also going in this direction itself. So, I highly recommend that when you start the machine learning engineer preparation, you should start all the way from the concepts and might not please do not skip anything when you're studying about this examination. So you have to cover each and every topic that has been specified here. You start from ML concepts, and the best way to take the ML concepts is the ML crash course by Google itself. So there's a Google Crash course for ML, wherein Google teaches, where Google they have created a lot of good material on this thing. They talk about all these five concepts like problem framing, processing, engineering, training, tuning, validation, and you should also be knowing the tools very well. So we should at least be knowing two tools, which is like TensorFlow or Keras very well. XGBoost is not a very much requirement, but they usually talk about it during the examination in one or two questions that I've seen. Next is when you move away from the ML concepts, that's how do you want to relate to GCP ML services, because that's the exam about. And I'll give you a quick tip, or maybe you can call that as a guru tip. Whenever you're talking about doing machine learning on GCP, always go in the direction which also Shri talked about in the pyramid in one of these slides. So you always should start about that in can you leverage any existing ML API or a pre-trained model? In case if not, then you go towards auto ML services wherein you can create models without doing any code, just by providing your data. And data labeling services is actually quite important, which provides you an option to label your own data set by Google. So they have humans who are working on this thing. You just provide your data, a guideline, and they will label your data within like a week or so. This is a very important service which is taken in this exam, and it probably comes up like in 2, 3 questions. Then moving forward, in case if let's say AutoML. So AutoML and BQML, they also work together. So BQML is BigQuery ML, wherein you are doing embedded ML inside BQ. So this is a very important feature as well, which is being taught mostly when you're talking about BigQuery. So in case if you see any question around BQ, bringing in BQ, then you can directly say that it's going to involve some aspect of BQML, or if not completely. All right, and um, then how you can move forward is at the end of that you have to focus a lot on the AI platform. So in AI platform there are inbuilt algorithms like XGBoost, then 10 time series analysis, and you can also build your own classifiers. So I mean, you just have to provide your data and you have to provide the label. You have to set some hyperparameters, and then you can train the models. If inbuilt algorithms that do not work for you, then you can go ahead for custom routines, which you can create your own custom training routine and run it on AI platform. So this is actually how you have to prepare. And in AI platform, there are two more topics which are very important. One is the batch versus online prediction, which has been brought again and again in the examination. Plus, what is XAI? XAI is explainable AI, wherein uh, let me tell you, I'm quite familiar with how the XAI feature has been built in AI platform. I have been using the other clouds, but I did not see the maturity like GCP in any other services by different providers as well. So XAI is a good topic. You have to study it thoroughly at least twice, because A lot of us are not aware about this initially. And moving from there, a lot of engineers, and when I talk to them, they tend to not think about the topics like ML ops. But let me tell you, machine learning without operationalization is just like you're building a car and you're just refueling it for once. You're not refueling it again and again and not making it available for more distances. Your car needs to go in further distances, and you need to be adapting with the change in roads and conditions. So that is exactly what your machine learning model needs to do. It needs to be adapting as per the changing data sets, changing business trends, and that's wherein machine learning operationalization comes into play. So you have to focus a lot on ML ops. ML ops in short is operationalizing machine learning, something similar to DevOps. That tells you how you can build a scalable pipeline for training, testing, tuning, and validation of your models, as well as deployment, all the way across from different platforms and different environments like your dev, queue, and prod. And then also continuous evaluation and drift detection so that you can train a model and maybe retrain it again automatically. So in this case, you have to thoroughly study about the TFX, that's the TensorFlow Extended. Kubeflow is again an open source platform built by Google themselves, and it is being asked in like at least one or two questions across in the examination. Then you have to also need to know something about how you can evaluate continuously your model. For this, their ML AI platform in GCP provides you a service wherein you can configure the continuous evaluation in the for a model, and your model is then tested by humans. So for a few set of predictions, the users or the data labeling services, the humans behind data labeling services, they give their own prediction for every model, and then the model's predictions throughout the time are matched. In case if the accuracy of the model goes down, that is an alarm and then can automatically trigger the MLOps pipeline. Second thing here, things like depth detection, wherein there are a lot of algorithms available. You can schedule those algorithms. And let me tell you, MLOps is not only possible through Kubeflow. You can also do it via MLflow. You can do it via Airflow. These are also some good techniques and good platforms or frameworks that are available. Then one thing which you should not be losing at all is data services on GCP, like Shri just talked. They are heavily being referred in the examination that how you can ingest data at scale. So PubSub, Dataflow, Data Fusion, they come into over there. You need to know about these services. All right, let me move next. And quickly talking about some of the sample questions that you would see. And these questions I've taken actually from the GCPML engineer examination guide. So let's take a pause. I'll read through some of the questions, and they're quite simple. But let me tell you, these are not exactly the sample of the examination that you would actually see. They're just a representation of the questions, the type of questions that you can see, but the level is not the sample of or not representative of the same of the exam that you would see. All right. So some of these questions are like, let's say you're training a machine learning model and you want to gain trust in that model. You want to give the end users the trust, and how can you do it? In this case, the correct answer is option B on the first question, which you can see over here, wherein you want to build the attributions. And for this, you'll have to go through the XAI topic basically on the AI platform thing. Then on the right hand side, you need to build an object detection model. Then how you can do it. So again, for this, you always have to start from the machine learning APIs that are available. So let's say you have to identify logos, and for that you have the vision API available. So in case you always have to, I mean, for GCP professional examinations, whether be it ML engineer or data engineer, the guide or the mantra is always start striking out the options that you see are not correct. And in case if you are not able to find, in case you end up with two or more options in the end, just try to choose the best one as per all the conditions, and that would be the right answer to all the questions. Then moving forward, there's also one more question
Just
that
one
let's
thing
say
I
you're
want
building a test.
Yeah,
Let's say
just
you're
one
building a
thing I
test.
want to add, right, Asan, I'm sorry to interrupt you. Just one thing I want to add. If you go to the previous question, basically, if you see over here, this were your knowledge of GCP is very important, because you will have question. If you see the first question, it is a generic approach, right? You use integrated gradient method to explain your model. If you see, the other options are not relevant because they are talking about explainability and trust. You K-fold validation gives you a sound model but not explainability. PCA gives you a data and lower dimension space, right? But if you take the second question, you have to kind of understand the question. You need to check for keywords that they're talking about custom solution, or they're talking about pre-available solution, right? If you see that pyramid that was there, the triangle, that's where what Asan was telling is, uh, take from the simple to complex. Okay, so that's what basically you need to do. Go ahead, Asan. I'm sorry for stopping
Yeah.
you.
That's okay. Yeah, I think and those are absolutely the right things. So, for example, if you want to take this question, if a team is building TensorFlow V3 CNN model, and you're using a pre-trained model, and you'll always see this. In fact, even in real world, you should never be jumping on a direct model or building a model from scratch. I've usually seen ML engineers doing that mistake. You should always start from something simple, try to see which pre-trained model. So you'll see the kind of same terminology is happening on the examination. You will see terms like pre-trained models or transfer learning or existing models. So that is something which you have to be aware. And this is a very good, I would say, advice for people who are freshers, basically who don't know much about GCP specific machine learning. So let's say if I pick up this question, which TensorFlow distribution strategy and AI platform, in this case, you would be using. So in this case, let's say you have 10,000 images and you see that all of them are having just one device strategy. So in this case, you need to know the TF distributor strategy topic over here. And if I talk about it, let's say if you have you want to bring in a custom tier with a single master node. If I take it option D, that would be very high. That would take a lot of cost, let's say. Okay, so in that case, you have to see, is the question referring that there is a cost reference or not? Is it referring that you have to choose go for a you want to optimize between the wall clock time or the training time, or do you want to optimize for lower pricing? Okay, so in this case, let's say if I choose option D, that could also be correct. But let's say if I go with option B, then is it even possible that I can use a one device strategy and four V100 GPUs? So let's say if I go with option B or C, that would be wrong, because in that case, if I go with option B or C, then I'm only using one device strategy. So I can clearly go either with option A or D in this case. And default strategy basically means if I go with default strategy, that would only mean that I'm going on the CPU. So answer over here is quickly question C, sorry, option D. And that is the right one for here in this case, that you store your all the images in a central storage and you let that run on a custom tier with single master node and four V100 CPUs. All right, so this is how you have to think about it. There might be a lot of questions which would be trivial, and some of these questions which are actually overlapping on data engineering. For example, let's say you're an ML engineer and you need to build an ML model to analyze video content. Now, this is actually a trivial question, because here in what you want to do is you want to identify objects in a video. Now, over here, you may think, if you know about GCP ML services specifically, then you can get confused. But let's start simple. So if it is talking about you need to build an ML or ML model to analyze video content, then you have to start from things like PubSub. It'll be there because it is a data coming in ingestion, and videos can be big. So in that case, you have to involve PubSub. That's good. That's there in all the options. Now let's say I want to eliminate cloud IoT because there is no IoT use case over here. So I can eliminate option B in that case. Then how can we eliminate cloud option A, C, and D? Definitely, I want to alert users. I want to also take some post action. So in that case, cloud logging is definitely involved. So I can safely also strike off option A and in this case. So option A and B are now gone. Then C and D are quite similar and are absolutely very similar. In this case, you need to know about the documentation that has been given by GCP. So in case if you don't know, Video Intelligence API is actually called as the Video Intelligence API. AutoML Video Intelligence is the second API wherein you can train your model. Now, in this case, uh, people might get confused that I want to identify my own objects. Why should I use the Video Intelligence API? And that's right to say. But let's say if they are already giving this thing and they've not mentioned that you want to identify custom objects in this case, then definitely don't apprehend that they're going with custom objects, you should go ahead with the option C over here directly. Okay. Now, with the last question, let's say you work for a large retailer, you want to use ML to forecast future scales. This is something when you have a lot of data in cloud storage in Avro format. So as soon as cloud storage and Avro format come into picture, you have to think about BQ or BigQuery in your brain. And this is coming from my intuition of the data engineering examination. So as soon as the BigQuery thing comes into play, I can say option A is correct, or option, so one of option A, or let's say something in BCD is correct, but I can clearly see that only A talks about BQML in this case. So I can clearly go ahead with option A. There may be some trivial things which could be have added in variations of this question, but this is my intuition around it. All right. So we are moving towards the end of this session. And I wrote a blog about this even on my Medium page, that how can you prepare about this, and we'll be sharing the deck. You can read through this whole blog very clearly. I've mentioned different topics. I've given different links how you can prepare about them, and specifically there is also something called as quick labs. I think a lot of people would be aware it is free for 30 days. That's very good. And people who so there are two options that you can practice on GCP. Either you can take a free trial, but I prefer the quick labs option because herein you don't have to register for a GCP account. You can directly go on this link, take that code for 30 days, and these all these three libraries, all these three skills can be completed in less than 2 weeks or so, and you'll still be left with credits for working on different other skill sets as well, like BigQuery or Kubernetes, for example, which is there. So definitely go ahead with this thing and practice these skills. Take these badges. Follow this link to move forward. All right. That's finally there, and this is the playlist by Shri himself. He started his own GitHub. There are a lot of, uh, I mean, even I saw a lot of these videos by Shri himself, and he keeps on adding videos. So you can go down to this link wherein he is adding a lot of playbooks and notebooks for you to practice. That's all from my side. I think we are open for questions now.
Yeah.
Thanks a lot, Shri.
Yeah, and here it is, right? Like, see, when you start learning Google Cloud AI, you have a lot of things. Your AI platform, Cloud Auto ML, APIs. That, like, you will have even the deployment platform, AI prediction engine, or Kubernetes, or App Run, or Cloud Run. Just take a look at my playlist. It's a new playlist that I have created for Google Cloud itself. I'll be adding more to it. It covers most of that. That will give you an intuition on how to get started with Google Cloud platform. And if you go to Google Cloud, you register, you get a $300 credit, make use of it. So that learning is easy because you don't have to spend for compute. You get the $300 credit, and a lot of this, don't try the auto ML vision alone with the $300 credit, because it will take the $300 in no time, right? Try other things will not even charge you $30 or $40 out of the $300 credit you get with Google Cloud when you register for a new account. Okay, so make sure the Cloud Auto ML Vision, don't run it. But other than that, you can try any of this that is given in this particular course, or you can use Quick Labs. You go to Google Cloud blog on every month beginning. They share like what are the free courses and information available. You can use that as well. Okay, so let's Hasan, go to some questions right now. If you
Absolutely.
see the professional ML engineer exam, now,
Mhm.
what they're talking about, somebody who has worked on the Google Cloud platform, has some experience. They are the best to take it, right? But tell me,
Right.
how hard for someone who has mastered data science but lack industry experience, and they want to take this certification? Now, what are the additional aspects that you need to look also before taking the certification? What do you think?
Absolutely. See, and that's a very good question. Basically, so people who are, let's say, very good data scientists, and I have a lot of such contacts with machine learning. So a couple of things that I would suggest them is, specifically if they're taking this examination, then they have to focus. I mean, they can leave this thing completely because they would be very well aware and very well experienced about this section. But they should definitely focus on this section, which is the GCP ML services. For that, I would say for them, quickly sign up on the Quick Labs free trial. Start with the libraries which talk about AutoML and BQML and AI platform. get that skill batch, I think that would be enough. And then they should also read about the AI platform's documentation. That's very well, and that takes not more than 3 days to completely go through it, like at least twice from that case. After that, I would suggest that in case if they're not well aware about things like ML ops, then they should read about ML ops, specifically in GCP's AI platform, GCP's documentation, and then also read specifically about TensorFlow Extended, which is actually a highlighted topic in this examination. That's my say to them.
Got it. Now the second thing is right, like if you see this particular exam content, it has like
Mhm.
4 or 5 modules. It talks about the end-to-end life cycle of machine learning, not the algorithms. Or so somebody has to know data engineering, ML ops, and there are
Right.
multiple aspects that come into play. So, how much of data engineering aspect one needs to look to know the certification?
Right. If I were to give a percentage, I would say somewhere between 20 to 20 to 30% is what is the data engineering aspect on this examination. And clearly, we cannot ignore topics like PubSub, data flow, data fusion, and BigQuery. They are something which are like the flagship services by Google on their platform. And with BigQuery using the machine, with BigQuery coming up with the ML embedded service, wherein you can directly do the BQML, and also the latest service coming on NL Q&A thing. BigQuery is definitely a flagship for Google, and also PubSub and Dataflow. So my say is focus on these three services at least. Read through them about what's happening in these three services and how can you build solutions which integrate with these three services, connecting with AI platform and also the ML ops. That's my say.
But and that was one of the question also. Like Syed has done professional data engineering certification. He has good
Mhm.
knowledge on TensorFlow, Qflow. What else I need to focus on? I think like it's like Syed, you have covered a pretty good amount of topics. You know TensorFlow, you know Qflow. I would say like just try to know the additional AI services that are there from AutoML or APIs or even like AI platform. But I think like with knowing data engineering is a very added advantage because
Absolutely.
it's an integrated exam, right? I would say like that's what Hasan also said. Like for a data engineer, yes, you need to know data engineering as well to some extent, right? So I think you are pretty good, but try to know the other AI services as well, Syed. Right. So I have like one more question, right? Now, what if you think like this is a GCP ML professional ML engineer? What percentage of questions here do you think were generic ML? If somebody does not know GCP and
Mhm.
they know like a generic machine learning,
Mhm.
uh, they are worked on TensorFlow, but they are not worked on GCP. How much percentage of question did you get from non GCP in this case?
Yeah. So there were like 60 questions, and out of these 60 questions, I think I saw close to 8 questions, 8 to 9 questions, which only talked about machine learning in general. And they were basically talking about this section over here that was the ML concepts. And those questions were not directly or straightforward. There were things around that could actually confuse you. That let's say you have images. Some questions were around CNN and RNN, or why would you choose CNN over RNN on a time series data set? And there were some questions which were quite complex or some trivial. But my say is somewhere around 8 to 10 questions, or you can attribute it to let's say 15 to 20% of questions were there on only ML concepts.
Got it. Got it. So let me take one question as well. I think Shakti had a question.
Mhm.
But I'm not sure how much it is related to. It's rate. Yeah, if you're asking Shakti in the GCP, right? How we can use live APIs like satellite or any live data API, and what can be the best way to integrate and work on use cases related to those data. Any examples of such pipeline? I think Shakti, like it's if it's a generic question, yeah, if it's related to GCP. Now GCP, you can see, you can use App Engine, or you can use your typical any cloud run or any engine to connect to APIs. If you are like getting data based on some parameters on the APIs, you can do it. You can build an event driven architecture. The reason I am like taking this question also, right, you need to understand event driven architecture. So one of the questions that you saw Like how will you use like video intelligence API? That is kind of a event driven architecture. So once you query it, you may kind of maybe get a response and you want to put it in a cloud pub cloud pops up, and then you will have like a consumers who are decoupled from your application, who are reading continuously from cloud pops up and then running ML APIs or further ML processing to it. So you can build a pipeline where you have applications running on app engine decoupled. You collect the data, put it into PubSub, and then use PubSub output to load data wherever you want into storage or process it.
Yeah.
So that is something like which you can do. And if you know that event driven architecture to really help you, I think some questions were in the sample questions I saw were part of it. You want to add anything, Asan, to it? You can go on.
Yeah, I think that's the right answer. And just to add, I think Shakti, to your question, I think she already answered it almost completely. So if you think about it in specifically related to GCP ML, so you have the data source and you know where to build the model. The only connection is how you can pull the data from the live API and put it in an ingested scalable way into the machine learning model or the pipeline. And that's when you know that the PubSub is the start. But then how do you fill in the data into PubSub? So there are things like you can build a cloud run service to pull data. And in that, let me add GCP ML engineer is or GCP any examination either on data engineer or ML engineer, you have to think about some things like how can you reduce the cost. So if you go for an option which is actually increasing a lot of cost, that would definitely be the wrong answer to any question. So you have to reduce the cost. You have to support scalability, that is horizontal scalability, so that you can ingest and process a lot of data together at once, and then your solution should be self-reliable, self-healing, and should be able to gauge for any kind of a spike or something. That is something which I also give from this question. I can add a trick to this one. Yeah.
So next question is, I think again, it's general. Like I observed that there are almost no opportunity for freshers in data science. How
Mm,
should a fresher get openings if opening are just for experienced professional? Uh, I know like it's pretty like frustrating, right? I'm not sure your exact name. I don't want to like call out that name. So here it is, right? Like what it's not that only experienced professionals as opportunity, but let me tell you how does a typical projects work, right? Now when we talk about like freshers hiring, typically a lot of company are just talking about AI ML and all, but they are not really embarked on a journey completely. And what we are seeing is mid last year and end of this year, the digital transformations have accelerated, which has in turn also see the more and more business solutions are accelerated using digital transformation. You will have more and more projects coming in on AI ML as well. And initially, if you what happens when you architect a ML solution, typically the cloud architects or ML architects are one get started, and as we get into the execution part of it, we will see like more and more companies hiring freshers. So it does take time, and I think like we are at this stage at least in the right point where a lot of fire freshers hiring have triggered off, right? It is not like as it was early last year. I'm seeing at least like a lot of opportunities are there coming up now. One thing from even an end user side I would say is build a good portfolio for yourself, right? I know it's too much to learn. There are we are flooded with information today, right? But you are the one who need to like separate out the signal and noise, see what is important, what is core to it. Enterprise, most of enterprise data are structured data. So 80% of the data are structured data, and remaining are basically text data, right? Natural language processing. Now what many people do is computer vision is really like fancy to learn.
mm,
We
mm,
typically end up spending a lot of data, but how many projects really are in computer vision? Yeah, the startups are doing a lot of work, but let's see the scale of it. And a lot of computer vision problem today can be solved with pre-trained models. For NLP, no, you need to do a lot of data cleaning and everything. Even for computer vision, yes, you need to do a lot of pre-processing. But think about it, what you need to focus on. Focus on core ML, foundational ML, focus on NLP, focus on time series, focus on that aspect of it. Try to build a good portfolio. Try to your certification is good. You are going to the courses and all, that is good. But try to also focus on cloud and scalable machine learning, right? That will also give you added advantage. A lot of companies are in cloud. A lot of startups do not have money to invest on infrastructure. They rely on cloud compute because you can just pay for what you use it. right? So there are a lot of controls you can make on cloud. I'm not telling cloud is cheap, because if you allow run to cloud, then that's it, the startup is
Mhm.
almost like without money. So you can control it, so learn that aspects of it, right? I think like it's opening up. We will see like a good year, because a lot of new transformations are getting started across company. Hassan, I know I spoke a lot.
Yeah. No,
Continue on.
that's
Hmm.
yeah. Let's take more questions. I think there are a few more questions which are flowing in.
Yeah. So what is it? How GCP ML certification will add value our resume compared to Azure ML and AWS ML? Go ahead, Hassan.
Yeah, yeah. And I think this is something, Shri, which a lot of people they ask. So, and let me before I answer this question, let me again state it. So this is my own personal view. What I see is these three clouds are they're really great. And if you see all the comparisons done worldwide, AWS seems to be running ahead at the first with as per those comparisons, followed by Azure and then GCP. But let me also put a point that Google has been doing machine learning since a long time. YouTube, Maps, and all, Mail, even the Android phone, everything, they have machine learning components since the time you can go back to like 10 years before, or even let's say 8 years back. And there's a lot of research done by Google, whether it is TensorFlow, whether it is DAG, Spark, in data engineering, data stack. And a lot of this has been tried and tested, built by Google itself. So the idea that I see is number one, my point is GCP is completely open source specific. Any component that you see on GCP, be it on data engineering stack or be it on the machine learning stack, is completely open source. They are very open source native specific companies. So if you specifically prepare for GCP ML engineers certification or data engineer, for example, then you're not only preparing for GCP ML engineer, you're preparing for an ML engineer certification basically. So you can take this information, you can take this knowledge across any cloud. And let me tell you, if you do this thing, then you can easily work on any place, whether you want to build a model in-house, whether you want to build a model on GCP. It's just that just by adding this small section over here is something specific to this examination. But if you see other concepts, which is concept one, three, and something which goes down as well, these are all something which you can scale up to anywhere, in fact. So this is my take is GCP ML. I would always suggest that it should be the first thing if you are moving towards ML in cloud, and then maybe you can move towards Azure and then AWS. But these views are my own personal, my own thought over it.
And one thing I want to cover also, right? Like the if you see the coverage of this GCP Professional ML, at the end of the day, you take the certification or not. I think somebody asked like how much does it cost to take the certification? Yeah, it costs around $200 to take the
$200.
certification. But if you don't take the certification, also the preparation is actually like you are preparing for your real world interview. There is a lot to learn from it. I would say just go at least the preparation side of it if you don't want to like take the certification part or right. So that's what I would say.
Yeah.
Hmm. So quickly, great presentation. Do you have similar presentation on Azure or plan to have in near future? I'm not sure about Azure. I am not Azure expert. I am finding someone to actually do it. But AWS is coming next Saturday, most probably. We are going to do a deep dive on AWS next Saturday. Not on the certification side, but all the data component side. Okay. And Asan, it's for you. People are really like sending you good vibes.
Thank you.
Then
Yeah.
yeah. So Syed has a follow-up question. Sources for ML certification, specifically reading material except Google Docs. Asan, can I?
Mm.
You want to go ahead and I will share my screen also because I've opened some of the links that you gave me. Okay,
Yeah, yeah.
so you
I'll
go
stop
ahead.
sharing.
Yeah,
Yeah, yeah. I've stopped sharing. So maybe
yeah.
you can also share during your time. So what we can do is so there are a lot of links that we want to specifically talk about, and I think she will talk about those links specifically. One is so ML Crash Course is something which is not Google documentation specifically, but then secondly, you should also read about um, I would say start with let me talk about specifically. There are a lot of Medium articles around the fact that how you can build it, but let's say if you are specifically looking for concepts on machine learning, basically, then you can take up the Coursera playlist by Google themselves that they have built on machine learning. So there are two courses by Coursera, by Google on Coursera. One is the GCP machine learning on TensorFlow, and the second one is GCP machine learning on TensorFlow advanced. And let me tell you, I also did these two a way year back, and this actually helped me build a lot of machine learning TensorFlow models on GCP. It helped me gauge upon that. I won't deny that it did not help me. These two are something two very important courses, and they're by Lakshmanan. So he is like preparing really good courses on GCP all the way on Coursera. These are two courses which I really highly recommend. And other than that, I would say practice on these quick labs. Quick labs actually will give you a lot of advantage on understanding what kind of questions can come up during the examination. I completely forgot to touch one base. If you think this examination is not completely theoretical, there would be some questions that, like three or four questions, wherein Google can ask you that what is this parameter that you want to tune, or what is the parameter of this function that should be provided in case you want to increase the capacity of, let's say, TensorFlow model server, or increase the queue size of all those things. And also, yeah, over to you, Shri.
Got it. So these are some links that Hassan shared before this one. This one I felt it was very good. It talks about a lot of architecture pattern specifically for GCP. You can just search for smart analytics reference patterns. I will add it in the video description as well, so that you can get it after this one. Here, there are a lot of like anomaly detection. You can go around the log analytics pattern. I know like there are too much things over here technically, but I try to understand the products that are getting used, how the particular end-to-end pattern, how the code is deployed. There are a lot of good case studies over here. This is one link. The data lifecycle, to understand the data engineering, data processing. Most of my images are taken from here. I've given the link in the presentation also, which I will share, and you can actually read a lot about it. Okay, there's a lot of details. I just try to condense it so that based on my experience where I am using it, that's what I did over here. But you can read this as well. This is like data lifecycle on Google Cloud Platform. This is a very nice link. These are all like, if you see, these are all pretty big documents. It's like a book. It is like a guide and reference material for you, not just some information that they have given. You can go and check the Mlops documentation where you can learn about Mlops. Now, if you see this particular course, right, the first is how do you frame a ML problem? How do you architect ML solution? These two are pretty common across all the platforms, right? So you can read about MLOps, how it is. If you come to my channel, right, if you go to the channel, go to the playlist section, you can see machine learning and data engineering courses. There are a lot of courses. And if you see this end-to-end machine learning, if you click on this particular playlist, I cover like a end-to-end machine learning, how it is. Basically, some of this first two sections, like how do you frame a problem, when to use ML, do you or when not to use ML, how do you go with business understanding, data understanding, and how the end-to-end flow look like. That is one thing you can check it. There are a lot of other things as well. I'm not biasing towards my channel. You have a lot of content. I'm just providing something that I have created. And here is the Google Cloud AI platform, where I have like both AI platform, how to deploy a model, how to do the data analysis, BigQuery ML. There are a lot of contents. I'm adding more to it. You can go and check that as well. Right. Again, to come again, I'm not biasing because just I have created the video. It's up to you. There are a lot of content available. There are Cloudera courses available. You can go and take it. So
Yeah.
those are things. Mm.
But Shri, I can say, I mean, again, I mean, it was Shri who was being generous by saying that you're not biasing. But let me tell you, and let me tell to all the viewers, the playlist that Shri has created, whether be it on Spark or be it on end-to-end ML engineer and all those things, they are actually much ahead of what I have actually seen on the courses. So you will only see him being stuck upon things which are really realistic, because these things, this experience is coming from the industry actually. So it'll only be something without noise and important things that you'll see on the videos, and you can actually practice together in the video. So if you see all those videos, you can practice together line by line, and you can actually work about on that. So my thumbs up are like Spark one is really great if you want to touch upon that, and ML end to end engineer that you can go as much and you can start directly with that.
Yeah, I think I
Yeah.
need to get more like you, Asan, who can talk about my channel. I will find people who talk good about my channel. Just kidding. So
Okay.
this is one more question, right? I have a model
Yeah.
which is deployed on on-premise. How can I retain the model which I'm getting actual label of an average of 3 months? Maybe you go ahead, Hassan, and I
Yeah,
can add.
absolutely. And Raja, this is a very good question basically, and this is exactly wherein MLOps come to play. So let's say there are two options, and there are two questions if I tell you. And you are actually right on that. So the first thing is you have a model which is on premise, and second thing is you get data every 3 months. So let's say you are doing you're building a model on premise. Now you may want to move it across different systems. That is one challenge. You may want to someday move it from on premise to cloud because your business may scale up. Second thing is availability of data. So let me answer the first question. If you're building the model on premise, then you should definitely go ahead with things like Kubernetes, number one, to have an environment to train your model, which means you should be referring to options like MLOps or Kubeflow, which can run either on your laptop or even on any local machine on a mainframe on your local environment or your enterprise environment, and the same thing can scale up to a cloud. So if you build a model that runs on Kubernetes, it can move anywhere. So that is the answer to your first question. Second thing is, if you get labeled data every 3 months, then this is something which you have to set up in your pre-training pipeline. So you can have in your ML ops or ML flow or in the Kubeflow that retrain the model every 3 months. You can set that in a recurring fashion. Pull the data in every 3 months from my data source, ingest it into my data, reprocess it, transform it, store it into a cloud storage or into a featured store, and then build a model out of it and then deploy it. Then you can build a in the final step of the MLOps, you can compare your results from the new model versus the previous model, and if it is better, go ahead and deploy it. And this will all happen automatically as a part of the MLOps. I hope that answers your question.
Yeah. I think you have answered it, so I'm not going. I don't have anything to add. MLOps is the answer for it. Let me go and ask, and like Raghav has said, thanks a lot to you. How can we get free credit to Quick Labs? See, one thing that you can do is go to Google Cloud blogs, right? Search for Google Cloud blogs. On every month beginning, they give you a list of free Quick Labs. So you can go over there. They will tell like, okay, December free labs, Jan free labs. You will find one in Feb. So that is one way to get Quick Labs. Also go into Google Cloud website, and in the certification there are a lot of learning path. They keep publishing free labs. You can go and check that as well. So I think like there have been a lot of things I'm publishing on LinkedIn, but you don't have to wait for me because I don't like publish every time. You go to Google Cloud blog and you will find a lot of information, or go to the individual certification pages. They will also have like quick labs and everything that you can use over there. Okay. I think this. I think we are done with the questions. Okay, yes, the slides and links, everything I will share in the video description. Just give me a couple of hours, and you can see it updated in the video description. I think that's what we have overall. And thank you everyone for joining. I know it's a Saturday. It's good time to sit and watch movie after a tiring weekday. But thank you for being here. And Hassan, more to you. Like, thank you for being here with all the power cut and everything you had. You finally like made it. But thank you very much. It was a nice informative session, sharing your experience, because not professional ML engineering, not like really a lot of people have taken it and cleared it. There are very few people, I think countable number of people who have done that, and you are one of those. And thank you for sharing your experience over here.
Absolutely.
Thank you very much. Thank you.